Okay, so question 6. What can be said about an exothermic reaction with a negative entropy change? So let's write out, when you have an exothermic reaction, then we know that heat is released. And when heat is released and you have an exothermic reaction, then your delta G value will be negative. Okay, so since heat is released, that means our delta H will also be a negative value. Since heat is released. And in the question, they say that it's an exothermic reaction with a negative entropy change. So I'm just going to say that delta S is also less than 0 since it's a negative entropy. Okay, so let's look at the Gibbs equation, I believe is what it's called. Well, where it's delta G is equal to delta H minus T times delta S. If we want delta G to be negative, then that means that our negative delta H must be greater than the T, must be greater than the second part of the equation. So since we know delta S is going to be negative as well, it needs to be a low enough value that it doesn't give us a positive delta G, if that makes sense. So let me write down the explanation. So delta G will be negative only when the value of delta H is greater than the value of temperature times your entropy. And I'll just put in brackets when entropy is negative. Just so that we're on the same page. So therefore, if we look at all of the different options they give us, it's not going to be spontaneous at all temperatures, because at high temperatures, delta G won't be negative anymore. So it won't be spontaneous at all temperatures. It won't be spontaneous at high temperatures. It'll be spontaneous at low temperatures. So we know that that's correct. Reaction is spontaneous at low temperatures. And different options, spontaneous in the reverse direction at all temperatures, so that's not true. Non-spontaneous in either direction at all temperatures, so that's not true as well. So here's the answer. They also got spontaneous at low temperatures. For the explanation, I'm assuming that these symbols just stand for delta. Delta G equals delta H minus T delta S. For spontaneous reaction, delta G is negative. Given that exothermic reaction with negative entropy change, delta H is negative, delta S is negative. So delta G is negative at low temperatures. Therefore, the given reaction is spontaneous at low temperatures. So this solution is correct. Okay, so let's